So we'll go ahead and get started here tonight. First of all, welcome, and thank you very much for joining us here on this night. My name is David Rauch. I'm the Director of Missions here at Chestnut Hill Academy. I couldn't be more happy and more pleased to bring you our first ever virtual robotics and engineering session. I've been the Director of Missions here at SCH for about 5 years. This program is one of the reasons actually why I chose to leave another local independent school and come over to SCH to be the admissions director. I firmly believe that the skill set and the mindset that goes on in Peter's classrooms and from the kids and throughout the entire school is really the best way to educate kids for the 21st century learning, and one of our premier programs here at the school. Just a little bit about tonight's program. In a second, I'm going to hand it over to Peter Randall, whose face you can see on the camera right there. Peter's in charge of our Robotics and Engineering Center. Peter's going to give you an overview of the program, both lower, middle, and upper school, then talk a little bit about the upper school. We have 3 students too as well, our captains from our robotics team, who each then share their stories, talk about when they came to SCH, where they came from, some of their accomplishments, those that are seniors, where they're going to school next year, potentially what they may be studying. And at the end, we have some time for questions. Some of you have already submitted some questions. We'll hopefully get to those at the end. If you have a question as we go along, please feel free to put it in the chat and we hopefully will get it to you. But it's now my pleasure to send it literally across the hall. I'm in one of the robotics classrooms, but I'm literally going to send it across the hall to Peter Randall, and he's going to start us off. So Peter, take it away.
Hey, good evening, folks. It's a pleasure to be with you. I apologize for our zooming camera. It does that automatically. Every time Vicky moves, it thinks she's the center of attention, which is appropriate. As Dave said, my name's Peter Randall. I actually am a CHA lifer. I started here 65 years ago as a pre-kindergarten student. And I have married a Springside lifer. My wife also started in kindergarten, and together we've raised 2 boys who are SCH lifers and are now off in the world. So been heavily involved in CHA, Springside, and SCH for literally decades. After graduating from CHA, I went on to college and graduate school, and then I spent about 30 years working in various high-tech industries before coming to SCH, initially as the Director of Technology with Chestnut Hill Academy. And in that role as the head of technology is where I began the process of getting involved with competitive robotics and developing the engineering and robotics program here at SCH. A couple of things that sort of motivated me in this process is that, I've discovered that in a world where everybody gets a trophy, kids only want to play games they can win. And that in a school where you only count mistakes, kids become extremely risk averse. And in an academic environment where grades matter more than learning, the questions are, is it on the test? Do I need to know it? Is it relevant to my life? Kids focus on remembering things rather than understanding them. And this was a critical element in the development of our program, that we wanted to focus on the thinking and learning process rather than the memorization and recounting process. So we're working on independent thought and reasoning, creative problem solving and design, teamwork and communication, the development of grit, resiliency, tenacity, perseverance, resourcefulness, and self-reliance. All the things that we know are extremely important to students throughout their life, regardless of what they pursue, academically or beyond. We literally ask our students to solve problems we know they don't know the answer to. We know they don't understand, and we ask them to figure it out. And it's the figuring out process that is the most compelling aspect of our program. They learn by doing, not by listening. I like to tell my kids that in my classrooms, it's all project-based learning, so there are no tests, there is no homework. And you usually get a big smile at that point because the kids all go, yeah, this is going to be an easy one. And then I say, but you'll work harder in this lab than anywhere else in school, not because I'm going to crush you on a test, but because I'm going to give you the opportunity to do stuff that's truly meaningful to you and provide the support necessary to be successful at it. So what does this look like at SCH? We actually teach engineering and robotics all the way from first grade up through 12th grade. And we do it in two fundamentally different ways. We do it as part of the curriculum, embedded into the day-to-day classes the kids take during the academic day. And we also do it as an after-school competitive activity. And again, we do it all the way from first grade up to 12th grade. So everything's project-based. What does it look like for a lower school student? So our curricular program is actually embedded co-curricular with math and science. So we've taken our projects and we've inserted them into the science curriculum. We've inserted them into the math curriculum so that the kids understand why they are learning the basics of science and math. It puts meaning to it. And the kids clearly enjoy it because they keep coming back and asking for more. We actually typically run an after-school program for lower school. For us, that's first through fourth grade. Unfortunately, this year, because of COVID and the fact that we're split into separate divisions, most of our upper school students traditionally mentor our lower school students, we're not allowed to do that this year. So our lower school after-school program is on sabbatical this year. But typically we'll have about 40 to 50 kids a couple of afternoons a week working on standard block Legos, building to purpose, which is the design and implementation process. So it's not just sitting around building Legos, it's building to purpose. And those purposes can be pretty wild. We actually present as part of an exposition hosted here at SCH, where we'll have 20 or 30 different schools all presenting their lower school projects. And it's very exciting, lots of fun. In middle school, we get a little bit more serious. Again, we do a curricular and an extracurricular program. Our curricular program is centered around our CEL program. CEL stands for the Center for Entrepreneurial Leadership, and it's where we house our experimental and enhancement programs within the curricular program. So in CEL, for example, every sixth grader gets a course in Lego design and programming. So they're building robots out of Legos and learning how to program them. They're programmed in a language called Scratch, so it's a graphics-based programming language, pretty easy for kids to pick up. So they're focused on the process of making the robots do what they want to do. And for this class, it actually culminates in a game that we play called Sumo Bots, where their robots try and push each other out of a 3-foot diameter circle. And I got to tell you, it's the most exciting thing we do on campus. The amount of noise that comes out of that classroom when kids are cheering on their partners and their opponents, and it's crazy. Tons of fun. Kids love it. And all the time, oh, they're learning how to program. Why? Not because it's on the test on Friday, but because they're having a whole lot of fun doing it. And that's what we're looking for. All our 8th graders take the course that uses a microprocessor to capture weather data. We actually fabricate this, the students fabricate the sensors and the computers to gather data in the Wissahickon out behind the school. And they collect that data to monitor the microclimate in the Wissahickon Valley and how it affects the biodiversity in the valley. It's a really pretty exciting program. It started last year, we're continuing with it. And again, the kids are building these technologically sophisticated device, easy for you to say, sophisticated device for a purpose, and that makes it real. Our middle school after school program is about 72 kids this year. Our 5th and 6th graders, again, will continue to use the Lego-based robots. They are broken out between the EB3 kit system and a new spike-based system. But again, it is a highly competitive program. Again, this year we are somewhat limited because of COVID to doing virtual competitions where we'll actually compete against teams by video. It's a little bit different than normal, but we're working really hard to make that happen and challenging for our kids. When we get to the 7th and 8th grade, we actually move up to a larger robot. It's called the First Tech Challenge. We use an 18 by 18 by 18 fabricated robot. I can sort of give you a quick gander here. This is an FTC robot. And you can see that the parts are made out of aluminum and plastic, and it's all fabricated. Again, the students do the designing, the fabrication, and the programming for that. A pretty exciting program. Most of the kids that do that continue into the upper school with our after-school robotics program as well. So when we get to the upper school, what's that look like? Well, again, we're split between curricular and extracurricular. Again, we have some required curriculum. Every ninth grader takes a course with me in microprocessors and circuit design. We teach them how to wire up sensors and other apparati on a circuit board, and then program that on an Arduino processor using the C programming language. They learn enough to be a little bit dangerous in the sense that they're not going to be experts in C programming, but they know enough to incorporate it in solutions as they look at more complicated problems down the line. And that's what we're looking for. Give them an exposure, give them a taste. They also take an app development course, which involves learning the Swift programming language. So they're developing apps for the Apple platform. And again, they're getting their feet wet, they're tasting it, and they're deciding whether that's something they want to continue with. Because when we get to 10th grade, we have a program that we call the CEL Capstone Program, where every student gets to select a one-semester project of their own choosing. They can write a book, record music, or they can build a product or start a business. It's up to them. We have a staff of about 8 faculty members and outside experts that help them mentor through the process, and they spend one entire semester developing their project. And some of those involve the Invention Studio, my studio, where we fabricate stuff, or they involve the microprocessors where we learn how to program in more advanced solutions. So one semester, everybody does it. Many of the students who work on a project in their sophomore year end up working on it continuously over their junior and senior year as well. And in fact, I have one student who just after graduating last year from University of Pennsylvania with a mechanical engineering degree, just took his capstone project to the marketplace. He is selling a 3D printer that prints chocolate. So he can fabricate any shape he wants out of chocolate. I got to tell you, it's terrific. And he started that project as his capstone project as a sophomore here at SCH. Carried it all the way through University of Pennsylvania and is now bringing the product to market. It launched about 3 weeks ago. Very exciting. And then sort of the pinnacle of our program is our after-school robotics program in the upper school. It's a 9th through 12th grade program. We compete against about 7,000 schools from around the world, quite literally. The typical year, we will compete against about 100 schools here in the Mid-Atlantic area, and then the top qualifying teams will go on to the World Championship in Detroit, where we'll have teams from all over the world competing. A lot from the United States and Canada, but teams from the Netherlands, from the rest of Europe, Africa, South America, all competing up in Detroit. And we've actually done quite well for a small suburban school outside Philadelphia. We have finished in the top 10 of the 7,000 teams 5 times. We finished 2nd, 3rd, 4th, 8th, and not this past spring, but the spring before COVID, we actually made it to the top of the podium with our robot that finished 1st in the world. So we're pretty excited about that. Let's take a look around. I'm going to introduce you to some of our students here. I'm going to start with one of our upper school captains. This is Julia, and she is sitting next to her favorite thing in the world, which is her robot.
Hi, well, I'm focusing on Ryan, but hi, I'm Julia. I'm a senior at SCH. I've been on the team for 4 years, which is also as long as I've been at SCH. I came as a freshman from Abington School District. So I am a co-captain. I am also on the mechanical sub-team. Oh, there's Ryan. I also am the driver of the robot during comp season, so that means that I maneuver the robot on the field. And Mr. Randall, can you show off the robot?
Not really. It's not turned on. But
I was one of a couple lucky people who got the chance to actually be on the field during the who got to be on the field during the 2019 World Championships, where we won the event, and that was.
Where was it?
It was in Detroit. We were on Ford Field. It was absolutely insane. There was thousands and thousands of people.
35,000 screaming fans, all for robotics, and pretty cool.
Yeah, it's great. And I intend to major in like astrophysics when I go to college, and that has largely been inspired by being on this team.
Cool. So
yeah.
Let's wander over a little bit. I'm going to introduce you to Ryan. He's another one of our co-captains. Hey, Ryan.
Hi everyone, my name's Ryan. I am a junior here at Springside Chestnut Hill Academy. I came here in 5th grade, and I've been on the team since freshman year. And honestly, one of the reasons I came to SCH in the first place was because of Mr. Randall and his amazing engineering department.
Same.
And just like Julia, I'm so thankful that I was able to be at Ford Field during the World Championship. I wasn't on the field like Julia, but I was sitting in the stands, and I was one of the 35,000 screaming fans.
And then finally, I want to introduce to Vicky, and Vicky is also a member of our leadership for our robotics team.
It's not zooming in on me right. Hi, I'm Vicky. I'm a senior at SCH. I have been here since pre-kindergarten, so that's 14 years. I have been doing robotics here since FLL.
Which was what grade?
Which was 1st grade for me.
1st grade for you. So this is your.
Yeah, they changed it around a lot, but
this is your 11th year doing robotics?
11th year in the robotics program with Mr. Randall. I feel like a senior citizen. It is so great to have grown up with this, because every step along the way I've been learning more and more about robotics, so I finally realized, this is what I want to do. So I am hoping to major in biomedical engineering when I go to college. I love it so much. It's been such a great environment. It's healthy, it's fun, and it's great really collaborating with everyone.
What did you do last summer?
Last summer, I interned at a prosthetics company, and I built fingers for amputees.
And what did you study last summer?
I became an EMT last summer, so I'm a licensed EMT on the robotics team, making sure everyone stays safe and we have enough fire extinguishers.
Yep, absolutely. So one of the things that's a little unusual about our program is that we build lots of crazy things. And one of the craziest is actually Ryan's project. And I'm going to swing this around and ask Ryan to describe what's hanging from the ceiling over here.
Sure, yeah, so that, believe it or not, is an airplane. This is our basement passion project, started in 2016, but actually from a capstone. It's a BD4C. Is a completely kit-built airplane. So as you can see, every part on flying in the skies right now was put on by a student. And unfortunately, because of COVID, we haven't been able to continue the project because it's been too close proximity working on the plane and everything. But over my freshman and sophomore year, we were able to, it started up out here, we were able to put on the entire tail, and then we've done a lot of interior work that you're not able to see.
Pretty cool. So a couple of other projects you can see in here. This is one of my favorites. This is a race car hanging from the ceiling, because that's where all race cars should be. This is actually an electric race car. It can go from 0 to 60 in under 4 seconds. I got to tell you, it's truly the most terrifying vehicle I've ever driven. And it's even more terrifying because it was designed by one of my sons, and he drove it rather recklessly. So kept Dad up at night. That's sort of it for our canned presentation. We have all the folks here who would love to answer questions. Let's swing this around.
Well, Peter, we definitely have some questions, and thank you guys.
All right.
Just go ahead and run down the questions. Some we got previous, and some we got while you guys were giving your presentation. So the first one that came in: can 9th graders participate on the robotics team?
Can 9th graders participate in robotics? How many 9th graders here participated on robotics as 9th graders? So the answer is absolutely. There are 2 elements to that question, actually, because really, A, are you eligible? Answer absolutely. B, if you're coming from the outside, are you disadvantaged? And the answer is no, because the technology between the small FLL robots and the FTC robots and the large-scale 150-pound robots is so different. Programming language is different, the hardware is different, the motors are different, that we all basically start over in 9th grade. So you will not be at a disadvantage. And in fact, most of our new members come in as new students in 9th grade. And right now we have about 60 members on the upper school team, and the majority of them are 9th graders right now. That's pretty cool.
I would say
So I know it's, go ahead.
freshmen get involved is their own level of how often they come. It's really self-advocacy for them.
We actually meet a lot, 2 to 3 times a week, but we don't expect any one student to come out to every meeting. So it's easier for us to offer many meetings, and then the student can pick and choose as they work around sports, work around other activities. Who here is involved with Players, our big theater group? So just last week, Julia had a lead in our school play, and she's a captain on our robotics team, and the driver and the mechanical lead. So the answer is absolutely, you can do many things. We're pretty good at working around conflicts and making sure that the kids don't get stuck in the middle. So we've had varsity football players, baseball players, squash players, ice hockey players all participate on the team and still be able to do their sports commitments.
Cross-country team managers.
There you go, cross-country team manager.
Well, you guys just knocked out a lot of the questions here, but one that just came in, what engineering classes are offered in the upper school?
Oh, I must have missed that one. The answer is they offer 6 electives. We start everybody off with a course in computer-aided design and manufacturing, learning how to draw in 3D and learning how to use the various tools that we have available for fabricating things. So we're very lucky. We have a slew of 3D printers that print everything from chocolate to plastic to collagen. We actually have a printer that will print human tissue. So pretty cool. We have laser cutters. We have CNC milling machines, a CNC router table. The students need to learn how to draw because all of these machines talk digitally to the design. So they learn how to draw the design using CAD, computer-aided design, and then they learn how to fabricate that idea using one or more of those tools. After our CAD class, we do a series of electives. There's an introduction to design and engineering, again, a project-based course where kids are allowed to develop their own projects. Many of the things you see around this room started out as student projects. The next course is an honors engineering class. The airplane and the race car were both products of the honors engineering program. That's a full-year course. We also offer a course in what's called real-time programming. It allows you to develop the skills for programming robotic systems. And sometimes it is manifested in an actual robot, and sometimes it's an automated system of slightly different fashion. So one of my students right now is developing a digital dog collar. It'll allow you to set a perimeter based on Google Maps, set up a fence, a virtual fence, and your dog will have to stay inside that fence because the collar knows where it is and it knows where the fence is and will alert the dog if they're approaching the fence. Pretty cool idea. Another student who's building a digitally managed hydroponic garden. So he's going to be raising lettuce in my lab with all digitally controlled, which is pretty cool. And our last course is a course in aeronautical engineering, and it is literally a course that will help you get your private pilot's license. So upon completion of the course, you will actually be eligible to sit for the written portion of your private pilot's lesson. And we've had a number of students that have gone on from that and gotten their license. I have a student who just this last spring graduated with a degree in aeronautical engineering from Princeton, having started both our plane building program, but also starting our aero engineering program and getting her private pilot's license before she graduated from high school. So pretty exciting stuff.
So we got two more questions. One, sort of going to the other end of the spectrum, in terms of the lower school, are there robotics competitions in the lower school?
There are. We do a classic Lego blocks-based design project. Teams are kids, 8 kids per team, and we don't do a competition. We do what's called an exposition, where they're presenting their idea and how they have manifest that in the Lego design. Very imaginative solutions for complex problems, but it's not an actual competition. It's still in the everyone's a winner world, and so everybody gets a medallion and a certificate, and it's a lot of fun. It's very cute. Kids are having tons of fun, and we actually host that event here at SCH, along with one of the first Lego League competitions, the larger Lego robots, usually in December. Obviously this year that's not happening. We also host the regional championship for Lego robots, which is again a middle school competition here at SCH. And finally, we host one of the qualifying tournaments for the large scale robots, which is a 3-day event in our field house, usually in March. Again, we don't know whether that's going to happen this coming spring or not.
Nice. So going back to the other end, somebody wants to know about in terms of where the kids end up in terms of colleges and what they actually pursue in college. Okay.
Well, the way I like to look at this is before we started this now almost 20 years ago, we were putting exactly 0% of our kids into engineering programs. And this engineering curriculum was designed to remedy that factor. We got to the point where we were putting as many as 20% of our graduates into engineering. As the school has gotten bigger, that number's come down a little bit, but we're still putting dozens of kids into engineering school. And they're going to Caltech, MIT, Princeton, Penn, Cornell, Columbia, Brown, Johns Hopkins, Carnegie Mellon, RIT, RPI, WPI, Virginia Tech. What?
All 3 military academies.
All 3 military academies. We have graduates that are flying jets for the Air Force. We have graduates that are designing ships for the Navy. We have graduates that are building every electric motor that goes into a Tesla automobile. That's one of our students. That's the production manager for that. And we also have a rocket scientist. We have a graduate who is now working for SpaceX, designing satellites for SpaceX. So yeah, we've got some really great stories out there.
Pretty impressive. So there's no other questions. I first of all just want to thank the kids for spending your time. You guys have been at school all day. You've been in school in person all day. And thank you guys for spending your time. Peter, always appreciate it. Everything you do for us. Thank you for those of you who attended our event for our first ever robotics virtual information session. We'll be sending out an email following up this. If you have any questions, please don't hesitate to email me, and I can pass it on to Peter or the kids to get the answers from them. Hope everybody has a wonderful night. And once again, thank you very much for joining us.
Bye-bye, guys.